Okay, in this section, we are going to be looking at the periodic table of elements. Why a periodic table? There are about 114 known elements, and as such, we would want to classify them, to organize them, such that we can each time refer to them and form a kind of database. And when we look at these elements, the elements somehow are different, but behave, some of them behave in a similar way. So we'll then have a basis of classification, of grouping. We'll group these elements into small groups or different groups based on the way they actually behave. So in this section, that's mostly what we are going to be looking at the periodic table of elements, how we group them according to what, and how the different groups actually behave, the different properties that they could have that will make us give them particular names as either metals or non-metals or semi-metals. Those are the three major factions that we'll be having. So let's see how we make up a periodic table. Okay, in the periodic table of elements, we will be having information about each element. It means when we look at that periodic table, because we've put all the elements in that table, we have some little information about that element, how the possible way in which it will behave, and we'll have probably its atomic size, its mass number and atomic number, and whether it's a metal, non-metal or so. So we'll have such kind of information. And when we look at the periodic table, we'll notice that every element in that periodic table is present in a particular block. It has its own block, and that block, where we have that element, it represents only one atom of that element. Understand that elements are more or less pure substances. It means that in one element, it's not like a compound. In one element, elements are made up of atoms. In one element, we'll see that each atom is the original or the exact replica or copy of the other atoms that are present in that element. So it's enough to just pick up the nature of one atom, which will represent all the remaining atoms in that same element. It's just enough to represent the nature of that one atom in one block, such that each element has its own block, which is represented by just one atom of that element. So what do we then put inside each of those blocks? We don't take the atom physically and put there, no, because we are just going to write out this table this time. We are writing it out, but whatever we are writing, we are representing the physical atom itself. So inside each of the block, we have the element's chemical symbol, which is actually gotten from the atom of that element. And with that chemical symbol, it's a letter. We also have two numbers, one up and one down. We'll see what they are as we move on. That will be the atomic and the mass number. Okay. So the elements in the periodic table are grouped together according to the size of the atom and the way in which they behave. From small size to big size. That's how the elements are grouped, because the sizes vary, but some sizes are similar. And the manner of behaviors are also similar, although these elements are all different, but there's just some similarities in their behavior. So we group them according to that. Hence, the elements are ordered or arranged in the order of increasing atomic number, with the highest or the lightest element, which is hydrogen, in the top left corner. Okay, the top left corner of the periodic table. We'll see, let's look at hydrogen in the top left corner of the periodic. So this is the periodic table. We will see hydrogen is here at the top left, and it is the first element in the periodic table because we start reading the periodic table from left to right and from top to bottom. So when we merge those two directions, hydrogen stands out as our first element in this periodic table, and it has its symbol, which is represented by capital H that we have here for hydrogen. Just like with every atoms, hydrogen has subatomic particles. We said there are 3 subatomic particles in our previous section when we were dealing with compounds. We talked about electrons, neutrons, and protons as subatomic particles. So, of those subatomic particles, hydrogen has just 2, but it has only 1 proton in its nucleus, which balances with 1 electron. Remember, the number of protons is equal to the number of electrons. Balances with 1, that's what I'm saying, it balances with 1 electron, which is spinning around the nucleus inside the orbits that we refer to as shells. Okay. When we look at the mass number of hydrogen, we notice that there is no neutron, or there are no neutrons in the nucleus. That's why with just 1 proton and 1 electron, hydrogen is the lightest element, the lightest of them all. So when we look at the periodic table, when we see the symbols, the atoms that are represented there, the big chemical symbol is the name of the element. And it has 2 numbers on the left side of that symbol. We'll look at that on the next slide. The smaller of the 2 numbers, the smaller one, it means not smaller the way it's written, but the smaller in terms of quantity. For example, 1 is smaller than 3, or 10 is smaller than 11, for example. So the smaller of the 2 numbers is called the atomic number, and the larger of the 2 numbers is called the mass number of that element. So what is the atomic number? The atomic number gives us the number of protons that are present in the nucleus of the atom of that element, of each atom of that element. While the atomic number again could also be the number of electrons that are spinning around that nucleus. And this is what happens in a neutral atom, where everything is balanced. Protons are positive, electrons are negative. Positive plus negative cancels one another to have neutral, 0 charge. So the atomic number then represents firstly the number of protons, but in a neutral atom, it could also represent the number of electrons. Okay, it could represent the number of electrons because in a neutral atom, the number of electrons is equal or is the same as the number of protons in that neutral atom. So the balance means the atomic number here in the neutral atom could represent 2 things. It could either represent the number of protons in the nucleus, or it could represent the number of electrons spinning around that nucleus in the orbits that we call shells. Now the next number, so we had the atomic number. The other number is the mass number. And the mass number represents the number of protons again added with the number of neutrons in the nucleus. Because the protons and the nucleus and the neutrons reside within the nucleus, inside the nucleus there. So the mass number is the addition of the number of protons and the number of neutrons. Remember, the atomic number is the number of protons alone. Now mass number is protons plus neutrons gives us mass number. It also then means that if we subtract For us to find the number of neutrons that are present, we'll then need to subtract the atomic number, which is the number of protons, from the mass number. It means you are taking out the protons from the mixture of protons and neutrons. What's going to be left behind? It will be the neutrons. So it means to find the number of neutrons, what do? We say mass number minus atomic number, and that will give us the number of neutrons in the nucleus. We'll use carbon as an example. What we see here is a block that is meant for the element carbon on the periodic table. Okay, so we've extracted that block so that we can now investigate all the information that we can get from that block alone. If we had the bigger picture of the periodic table, we'll see the group also to which carbon belongs, whether it's a metal, non-metal, or semi-metal. From this image here, we can already identify three things. We can identify the symbol, which is the letter capital C. And from this symbol, we can now work out the name. That's why we get the name carbon. So in a block, we can also find a symbol which will give us the name of the element. So from this symbol, we got the name of the element. Our element is carbon. Secondly, we will have a number, two numbers actually, one here and the other one. Previously, we talked about a small number and a big number. Between these two numbers, 6 and 12, which one is small? 6 is small. So the smallest number of the two is what represents the atomic number, while the largest number of the two is what will represent then the mass number. Remember, the atomic number is the number of protons present in the nucleus, and the atomic number could also, in a neutral atom, give us the number of electrons. So the atomic number is for two things, for protons and electrons, while the mass number is for protons plus neutrons. Please, there's a difference between these two things here. In this case, I talked of, for the atomic number, I said proton or electron. There is an or here. Meanwhile, for the mass number, I said proton plus neutron. So this is a representation of the diagram of the carbon atom with the orbits, how it will look like. We will see here it has 1, 2, 3, 4, 5, 6 electrons that are orbiting around, that are moving around the nucleus. This is the nucleus here. That are 6 electrons that are moving around the nucleus in energy levels that we refer to as shells. Okay. Now, in the nucleus, when we look at the nucleus, we will see there are 6 protons. You will see here, protons are positively charged, electrons are negatively charged. Okay. In the nucleus, there are 6 protons in blue here to balance with 6 electrons. That's what makes it neutral. Positive plus negative is neutral. Okay. And also there are 6 neutrons. Neutrons have no charge. They are neutral. That's why you see there's no positive or negative sign on them. So that's what we have here. This is an example of how a block of an atom representing the element will look like in a periodic table. Again, we have the symbol to show the element. we have the atomic number, which will give us the number of protons or the number of electrons, and we have the mass number, which will give us the number of protons plus the number of neutrons. If you want to obtain the number of neutrons, we say 12 minus 6. Okay. So to get the number of neutrons, we will simply say 12 minus 6. Otherwise, we will be saying mass number minus atomic number should give us the number of neutrons.